Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. So today we kind of have a general problem. This is going to be a breadth problem if you're taking the PE exam. If you're taking the FE, expect this type of problem as well. This is certainly something you need to keep in the back of your mind whenever you're prepping for these exams. And here's what the question says. A particle is moving along a straight line. The velocity and location are both zero at time equals zero. The particle's velocity with respect to time is v of t is equal to 4t minus 7t squared. And then the question is, what is the position of the particle at t equals 3? We're not given units, don't really need units. And then we give our four options there, 3 and negative, 1 and positive. So basically, it gives us a formula for velocity, and it's wanting us to figure out where this particle is when time equals 3, right? And so if you guys remember something, there's a little trick that I was taught in school, and it's the fact that velocity is a derivative of position, and acceleration is a derivative of velocity. And so that's kind of what this is what it's going to look like. I'm just going to write remember right here. So your position, which is s of t, right? Typically position is going to be an s. That's kind of what the standard is, I guess. And then you have velocity, v of t, and then you have acceleration, a of t, and you derive as you go down. So derive here. Actually, I need to move that. So I'm gonna actually show you the trick on why this works. But let's go ahead and think real quick. So we have feet per second, right? And this is kind of how it works: feet per second squared. All right. So you have position, which is just itself, and then you derive position, and so this guy is actually ds with respect to t, right, over dt. Right? And then the acceleration is the derivative of velocity. So we have dv with respect to t over dt. And that lines up well with our units: feet squared, feet per second squared. So, sorry, feet per second, and feet per second squared. Sorry about that. And so what we can do here is we can actually, we understand we're given the velocity, right? We're given this guy. Let's see if I can do that. There we go. I've never been good at those. Let's see if we can use this guy and somehow solve for position. You know, integral. Integral is how we're going to do this. And so to kind of write this out here, our s of t is equal to the integral, which, by the way, is the opposite of derivative. So if you're watching this, it's been a little bit since you've been out of school. They have a couple sections in the manual that kind of walk you through this, but I would watch some YouTube videos on how these dudes work if you want a good refresher. The manual isn't very helpful, in my opinion. And so what we need to do is we need to take the integral of velocity in order to solve for position. And so what this looks like, whenever we plug in our formula, the position with respect to t is equal to the integral, and we plug in our formula here. This is going to be 4t, right, minus 7t squared. That's where that comes from. And then we need to write dt at the end. That's just one of the rules there. And so when you do this, if you've forgotten what an integral is, I'll walk you through this step here. Basically what you do is you add an exponent and divide by that new exponent. And so in this case, we're going to have 4t squared over 2. And then we subtract out 7t cubed, because we add the exponent, and then divide that by 3. And then we have this c at the end. Don't forget that c. And the reason why is because they included a very important disclaimer. This c is called the constant of integration. But they included a disclaimer up here in the problem here. It says the velocity and location are both 0 at time equals 0. Not a straight line, but imagine that it is. And basically what that means is when s of 0, so when time is 0, the position is also 0. And so what we can do is we can plug in 0 into t into this new equation that we found, and we can solve for c because it gives us that sort of equation. So let's say theoretically, this problem just basically says up here s of 0 equals 0, right? And v of 0 equals 0. But let's say theoretically, when let's say the position is 1.5 when t is 0.75. Okay, what you would do is you'd go s of 0.75 is equal to 1.5. That's what that would look like, and you would plug in this 0.75 into this formula and set it equal to 1.5. Okay, so that's kind of how that works, and then you solve for that c. So not significant in this problem, just wanted you to know that. So if in the event on the exam they actually do something like that, you need to know how to do that. And I erased too much here. So all right, so let's plug in s of 0. So s of 0 is equal to 0, which is equal to 4 times 0 squared over 2 minus 7 times 0 cubed over 3. And then we have that plus c. Well, whenever you solve for that c, it ends up being 0, right? All right, so the c goes away. So now let's rewrite our equation, but now we can plug in our 3. It's wanting to solve for when time is equal to 3. All right, so we need to plug in that 3 into our formula that we solved, that we derived into a position type of formula. And so that's what we're going to do now. We're going to go s of 3 is equal to, we don't know yet. All right, so we need to solve for that. 4 of 3, right? So 4 times 3 squared over 2. Subtract out 7 times 3, okay? We're going to cube that and divide by 3. And remember our c value, don't forget that. Let's say theoretically it ends up being like 1.25 or something. Don't forget that. It could change your answer significantly. And so in our case, it was 0, so we're going to go ahead and add 0 at the end. And hey, while I've got you here, if you've already enrolled in one of the review courses at civilengineeringacademy.com, keep it up. You can do this. If you haven't, I encourage you to go to civilengineeringacademy.com to check out some awesome practice exams and resources that will help you pass your FE exam and PE exams the very first time. And so when you solve for this guy, when you solve for S of 3, right, so the position when time equals 3, you end up with negative 45. Didn't give us units, so units are not significant in this problem. And it looks like we're looking at B. And so I hope this video helps, and we'll catch you next time.